Hi class, let's take a look at example 6. Now, example 6 could work perfectly fine with the power reduction formulas. You could actually use, in this case, it's set for formula 28, but that's not actually part of the instructions. And the problem here is if you were to use the actual formula, since it contains an integral, it may make the problem too long. So there may be like another shortcut. In this case, the shortcut that they want us to use is that sine squared plus cosine squared is equal to 1. Okay, so let's actually, we'll start with this problem. And in order for us to utilize that formula, we're going to have to somehow rewrite the sine squared. Well, actually, sorry, the sine to the fifth power into sine squares or cosine squares, and then try to use some u substitution that would help us. So in this case, the most appropriate step to do here is express the sine as an even power because, well, we need a 4 to extract the squared so that we can actually use, well, sine to the second power for one of the actual pieces of the problem. So what I'm going to do here is I'm just going to say or rewrite this one as an actual, well, sine to the fourth power of x times the sine of x dx. And in this case, this is supposed to be to the fourth power. Well, in this case, I'm just going to rewrite it. And notice that to the fourth power, it's technically a squared. So I'm just going to rewrite it as sine squared of x squared, that will be to the fourth power, times technically the sine of x dx. Now, there's no advantage of actually using this format without having a cancellation. And if they want us to use the actual, well, cosine squared plus sine squared, we want this to cancel. So the most appropriate substitution to do here, it's basically saying that, well, in this case, sine squared of x is equal to 1 minus the cosine squared of x. So our integral, it's actually going to look like this is the integral. And remember, you still have a 2 to the second on the outside. So this is 1 minus the values of cosine squared of x, technically squared, sine of x dx. And that is once again our sine. And then depending on which steps we actually take here, or if you use a different breakdown for the sines, our actual solutions may not look identical. So we may end up with, well, we may be off by a constant. So here, if I want to use a u substitution, I'm going to do the following evaluation of this problem. So I'm just going to rewrite it as 1 minus cosine of x and technically squared. So I'm just expressing it in a different format. And then times a sine of x dx. And I'm just going to let u equal to, I just want the cosine. This is so that we can cancel this term here and we don't end up with a chain rule. And the chain rule actually led us to we're stuck in the problem and we cannot actually simplify it. So then du is equal to a negative sine of x dx. Okay, so rewriting the problem, it's actually going to give us, whoops. This is the integral of 1 minus technically u. We still have the squared. Oh, I'm missing the squared here. Times the actual sine of x, and we're supposed to have du over negative sine of x is equal to dx. So let me rewrite that portion. So we're looking at du over the negative sine of x. And what we want is for this portion to cancel. Let me rewrite the entire integral here. And notice that we have a negative. So this negative, I'm just going to put it on the outside. So this is negative integral of 1 minus u squared du, which is going to be equal to negative integral of 1 minus u squared times 1 minus u squared du, or negative integral, and we're just going to get a 1 minus a u squared minus a u squared plus a u to the fourth du, which is just going to end up with negative, and let me just put a parenthesis there. So the first term is just going to be a u minus a u to the third over 3 minus, wait, there's two of these. Sorry, let me actually combine these. So this is just going to be minus 2u squared. So minus 2u squared, or minus 2u to the third divided by 3 plus a u to the fifth over 5 plus your constant, and then we still have that negative on the outside. So multiplying the negative, it's going to give us a negative u plus 2/3 of u to the third minus u to the fifth over 5 plus c. And then let me evaluate our main value of the u, which is going to give us the final answer. So we're going to end up with a negative cosine of x plus 2/3 cosine of x. This is to the third power minus a cosine to the fifth power of x over 5 plus the constant of integration. That would be our final answer.